So I'm going to be talking about the Munali nickel deposit in southern Zambia, specifically looking at the nickel, copper and PGE mineralisation and using this to justify the case for a missing copper ore body. So this is all work that's been completed as part of my PhD at the University of Leicester, but I'd just like to acknowledge and highlight everyone in here who's all been involved in the various aspects of this work. So Munali is situated within the Neo-Proterozoic Zambezi belt that separates the Congo Craton from the Kalahari Craton in southern Africa. So the Zambezi belt is a northwest-southeast trending orogenic belt that's marked by a series of parallel shear zones, and the most important for Munali is the Munali shear zone. And this is highlighted on the right, how it's prospective not only for being associated with the Munali nickel deposit, but also is associated with other sulfide-bearing mafic ultramafic intrusions, as well as Chikani, which is a copper-rich black shale deposit, with additional evidence for artisanal gold workings in the region. So if we zoom in along this Munali fault, we can see that it's highlighted topographically by a ridge, and this marks the Munali Hills. And it's at the base of this Munali Hills that we've got the emplacement of the dynamic mafic ultramafic complex that is Munali. And this comprises an elongated, lozenge-shaped intrusion, about 2 kilometers in length and around 500 to 700 meters in width. So as mentioned, the Munali complex is situated along the fault zone, and this is highlighted by these sheaf-folded lamprifiers. Additionally, the complex itself is hosted almost entirely within deformed metasediments during the Pan-African, notably the isoclinal folded marbles. The intrusive complex itself is steeply dipping around 70 degrees to the southwest and comprises a central unmineralized gabbro body surrounded by a marginal mafic ultramafic unit, which is the host to the sulfide. And this unit is thickest along the southwestern margin, whereas the sulfide is not continuous along strike, but instead forms a series of pod-like prospects, which includes Intrepid, Voyager, and Enterprise, the site of the nickel mine. We also see slivers of mineralization along the northern margin, which is Defiant. So if we look at drill hole sections across the various prospects, we can see that the complex is characterized by similar profiles throughout, where we've got a marginal gabbro, weakly mineralized marginal gabbro and an unmineralized central gabbro with ultramafics and sulfides at the contacts. However, it's Enterprise that shows much more significant quantities of sulfide compared to the other prospects. So if we look specifically at Enterprise, we can see, just looking at the nickel and copper ratios, the copper is rarely above 0.5 weight percent, but we see sulfide associated with big peaks in nickel with up to 4 weight percent. And this highlights what we see characteristically is this high nickel copper ratio of the Munali ores. Additionally, although we see sulfide associated with ultramafics, the ultramafic rocks themselves are not the direct host to sulfide mineralization, and this is seen where we've got high MgO associated with low nickel copper, palladium platinum, and low cobalt and sulfur. So if we look at a cross-section from underground mapping across strike of Enterprise, we see that it nicely correlates to what we see in drill core, where we've got the marginal gabbro, sulfide and ultramafics, and then this central gabbro. Although we have mentioned that the central gabbro is barren, it does actually host sulfide-rich carbonate veins that propagate away from the ore body. And Enterprise itself has been described as a chaotic megabreccia, but what we highlight here is that even though we get a variation in brecciation textures, the sulfide itself is present as a series of number of sheets throughout the ore body, the most significant being at this ultramafic central gabbro contact. And if we zoom into this ore body, the sulfide-rich ore body, shows a schematic of the different variation brecciation textures that we see at Munali. Characteristically, we get these football carbonate veins that become more carbonate-rich away from the ore body. And the highlight again is that although we've got ultramafic rocks associated with sulfide, we only really see them being the host of sulfide where we get this pseudo-interstitial texture along the margins of this massive sulfide, representing this infiltration of a sulfide liquid. So it's around here that we see this soft-walled brecciation style, where we get these rounded centimetre-sized ultramafics, commonly dunites, hosted within a sulfide matrix. And in this image, we see that we've got this infiltration of sulfide into the ultramafic rocks. But we also see characteristics this hard-walled brecciation style where we get blocks of meter-sized gabbros hosted within the sulfide. And on the image on the right, nicely shows how we've got this brecciated gabbro blocked hosted within sulfide. So this is all evidence that we've got a late-stage sulfide infiltration after full or partially crystalline mafic and ultramafic rocks. So one of the questions is, what is the source and the mechanisms for forming sulfide saturation and forming a sulfide liquid? And we've tried to answer this by looking at sulfur isotopes. And what we can see is that the bulk of this sulfur shows a homogeneous signature between +4 and +7 for sulfur 34. And if we compare this to the country rock sulfur signatures, we see that we've got a schist that shows isotopically like signatures. Black shale, that although shows similar delta 34, actually is out of range within error from cap 33, so unlikely to be the main contaminant, with the most likely being sulfur from the direct marble host rocks, which shows a heavy sulfur 34 signatures, suggesting that we've got a mixing of a crustal component with a potentially magmatic component. So here's all evidence that we've got a crustal sulfur contamination forming the ore body. However, when we look at sulfur-selenium ratios, we see mantle-like sulfur-selenium ratios, which is at odds to what we see from the crustal contamination. So using the fields of Griffiths and Barnes, there's likely been a magmatic or post-magmatic modification to what we would see is that if it's got crustal sulfur, would be high sulfur-selenium ratios, but we've had a shift lowering this ratio. And two possible mechanisms for Munali is that we've got a magmatic process where we've got an increase in of R factor of the ores, or potentially we've got a post-magmatic modification where we've had crustal assimilation followed by high-grade metamorphism. So we've tried to characterize Munali both geochemically and on sulfide textural styles. So we see a variation in sulfide styles throughout the ore body and associated with the different sheets. And these are typically comprised of semi-massive sulfide associated with a variation in gangue minerals, including serpentinized dunites, mafic rocks, coarse-grained apatites, and carbonates. But what is important to note is these last two samples where we've got sulfide associated with talc carbonate in highly deformed zones, as well as sulfide associated with these calcite-rich footwall veins. When looking at the sulfide geochemistry, and if we compare nickel and copper ratio, what we can see is a nice trend in the interstitial sulfides and the semi-massive sulfides, going from unmineralized samples, trending with nickel ratio of around 7 to 10, up until the massive sulfides, where we see a wide variation in the nickel copper, ranging from less than 0.1 to up to 70. And this variation is happening irrespective of sulfide styles. So if we compare metal tenors here, looking at the nickel tenors versus copper tenors, we see that this variation is mainly linked to this wide variation in copper with a relatively minor variation in nickel. Similarly, a similar trend is seen when looking at copper and palladium tenors, where we see again this wide variation in copper with relatively minor variation in palladium, suggesting that we have had a either magmatic or secondary process that's affecting copper, but is unrelated to the nickel and palladium. So when looking at, we've looked at sulfide textures of the ore body show a series of these tornado XRF maps that were completed at CSIRO. And the first image shows what's characteristic of the Munali ore body, where we've got these coarse-grained pyrrhutites surrounded by these exsolution pentlandites in pink, with only minor chalcopyrite associated with these loops. And this is typically representative of a magmatic sulfide origin. However, we do see areas where localized deformation, and this has caused a visible variation in chalcopyrite modal abundance. So in the first two images is where we've got pentlandite forming these planar fabrics and also forming around the class. And this is associated with low percentages of chalcopyrite, whereas in the bottom image is recording a snapshot of this mobilization in progress, where we've got chalcopyrite forming stringers moving away from the main sulfide mass. So we are seeing evidence for localized chalcopyrite mobilization. However, as mentioned, the bulk of the ore body refrains this primary magmatic texture. However, what we do see is where we see this magmatic texture, we do see chalcopyrite rich field fractures potentially represent this a mobilization of a chalcopyrite rich liquid or copper rich liquid during crystallization. So if we look at the platinum group minerals, the bulk of the PGMs at Munali is characterized by a dominantly palladium platinum rich bismuth tellurides, and these are hosted by all the sulfides present, being pyrrhotite pentlandite, chalcopyrite, and pyrite. However, we do see what we refer to as a secondary PGM assemblage at Munali, associated with the talc carbonate shear zones and the carbonate sulfide bearing footwalls. So in the top images, we've got the PGMs as palladium tellurides and palladium antinamides, as well as bismuthides, hosted entirely within silicates, but in close spatial association with the pentlandite. And these styles are also associated with rare electrum. And notably in the bottom right images that we've got tellurium tellurides as PGE pore tellurides, and here we've got bismuth tellurides, but hosted within pentlandite. And this is interesting because if we look at palladium in pentlandite, the bulk of the ore body forms this has a high palladium in pentlandite, which is typically representative of a high temperature magmatic pentlandite origin, whereas where we see the secondary PGMs are associated with low palladium in pentlandite, suggesting that although we've got the bulk of the ore body forming as a from a magmatic sulfide, high temperature magmatic sulfide, we do see localized geochemical variations likely due to either deformation or hydrothermal fluids. So fitting this in with what we already know about the Munali complex, if we rotate the complex of this schematic image to the pre-deformation and the morphology during emplacement, we've first got the emplacement of the central gabbro, followed by the marginal gabbro and ultramafic rocks. And it's during this stage, after partial crystallization of these units, that we've got the sulfide infiltration and microbrecciation. So this is characterized where we've got an infiltration of a homogenized sulfide, due as shown by the homogenized signature of the sulfur isotopes. And what we see of the bulk of the ore body is that it represents a typical MSS portion of a sulfide, principally comprising pyrrhotite and pentlandite. However, what we see happening on this centimetre scale is potentially happening on a macro scale, and we could have a mobilisation of a copper-rich liquid after crystallization of the MSS. So if this is a potentially likelihood for what's happening at Munali, if we then deform the ore body and move it to the present day morphology, even though we've got localized copper mobilization, we potentially have the copper-rich liquid that is now crystallized at depth. So we've seen that we've found the Enterprise, Intrepid, Defiant, and Voyager prospects. So is it a possibility that we've got a copper-rich discovery ore body at depth? So thank you for listening, and feel free to add any comments or questions in the discussion, or you can email me after this talk. Thank you.